All right, gentlemen, I'll be right with you. Okay. All right. Doo-doo-doo-doo. All right. So let me see. Welcome everyone. I'm glad you all are back. You all are doing well. At least if you're here, on some level you are. Um, given the climate of everything, I just want you to be aware that with all the things that have gone on, you survived 100%. You know, of all the stuff you've experienced, right? Just let that sink in for a moment. Like we've all kind of been through whatever we've been through, but we've survived it thus far up until this point. Um, get the student. Does anybody care to share like their experience, like either how they're doing, where they are with the material, or how their weekend was? Who is this? Okay, I think it's this student. Please show your first and last names. It helps because if I don't see it, then I'm like, wait a minute, who is this? Okay. Yeah. Anybody want to share, like, care to share their experience, like where they are, how are they finding the material? Like, for instance, one of my students earlier, he was like, he's taking another class as asynchronous. I didn't realize that professors did that. He was like, they don't meet like in the Zoom. It's just the stuff is there, and they just get assignments. And he was like, it's hard to know if anything is going on. So I don't know. Like, I was just opening the floor just to check in to see how everyone's doing. Did anybody want to share? How they either finding the material or how are they just doing in general, or how was their weekend? Just something about you guys. Let me check. Yeah, my audio's working. Okay. I can't seem to get any takers, so I'm gonna let me see. Let me hop over here real quick. Oh, Han, go ahead. Yeah, yeah. Just feel free to unmute yourself. Hmm. 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 Well, I'm actually glad that you shared that because you do realize you can still work on it, right? Yeah, yeah, yeah. You get unlimited attempts. So you see, like this is. I'm so glad I did this. This actually makes me feel good. Yeah, it's not set. So my assignments have a default built-in extension. The way I have it set up, right? So even though it was due this morning at 9, you can actually still work on it past the due date. It's just a 10% late penalty. So the highest you can get at that point is a 90. But a 90, which is an A minus, is way better than I'm pretty sure where it is right now. So but you get unlimited attempts, and it's set to take the highest score. I've had students that literally waited to the end of the semester and submitted it. I was like, okay, well, you gave me what I needed, so I was able to use it and kind of keep it moving, right? So I'm so glad we had this conversation. So now you can like go and improve that score. Okay. Uh, yeah, yeah. There was another hand. Mm, wow, that's interesting. I don't usually hear people say that about Chicago. Um, because usually it's the other way. Like my dad is actually from Chicago. He was from Harvey, Illinois. And I think he was born in Alabama. He grew up in Chicago, and he settled. Hang on, he settled here in Georgia. Hang on, and like, but Chicago's interesting. I was watching something on not the Daily Show. I'm just letting students in. I have a student at Baldwin. Okay. There was this show. Okay, so I just let someone in, Baldwin. I don't have you on my roster, So I'm just letting you know. So if your last name is Baldwin, I don't have you on my roster. You might want to look into that and make sure everything is okay, or make sure you're in the right place. Hopefully everything, I'm not going to worry about it right now, but I know how to take charge of it. But yeah, so there's this on Apple TV Plus is a series called Home, and like basically what they do is like you have these people that like just turn their homes into like architectural artwork. It was like artwork, and so they showcased this guy in Chicago where he took these homes like he when he was buying them, everybody was like, "Oh, don't buy that. That's a rundown place." And he was like, "No, I see something in it." And so he took these like abandoned places, and he turned them into like these beautiful like community spaces. I was like, "Oh," and it was like people were doing like art shows, and I was like, it totally inspired me. I was like, "Oh, that is beautiful." And like where nobody saw the value in it, but he was determined to not run away from his community. He was like, "No, this is my home. I have to build it up." So he took these abandoned buildings and like basically turned them into art. And like, I mean, the value of it just went through the roof because he essentially stood his ground, and like he didn't run from it. He actually took the time to like, you know, greetings. Yeah, if you're in my tennis, I got it. If you're in my roster, if you're in the Zoom call, aside from the one person, um, the person that I didn't get was Baldwin, I think. Because I just don't see you on my roster. Let me look again. Yeah, I don't see you, but everybody else I got. But yeah, I just don't hear a lot of people talk about going back. But that was refreshing to hear you say that. Like, I was like, because I visited, but I haven't been in a while. Anybody else want to share before we just kind of talk business stuff, like about the weekend? I know there was another hand or two. Uh huh. Hmm. Okay. Did you did you have family like affected by the flooding and stuff? Where was the flooding? It was further north. Oh, okay. 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 Hmm. Okay. Where were you able to contact Dr. Lamar for Alex? Mm-hmm. What was your question with Alex? So Alex, my okay, so she is the point person for that. My understanding for Alex though, it's like you signed up for it when you were like doing a new student orientation. You had to take like a placement exam. Alex, and you can actually still log back in right now with your same credentials. And with the way the Alex Lab component works, you basically just continue where you left off. Um, and like I think she wants you like more than likely she probably wants you doing at least like 55 topics a week or something like that. It's something like that, but she has the details. But Alex is just a lab component, and so like basically what it is. So for class, we're using Pearson, right? Pearson is like our online management for the stuff for college algebra. Alex, let me see. Yeah, I got the student. What Alex does, Alex goes back and based on, when you take your exams, based on what the questions that you miss or whatever, it creates a curriculum that's customized for each student, right? So that's what Alex does. So that's the lab component. She has the details on that. Yeah, but that's the long and short of that. Um, and so she's logging like she can see all the students' information and see what everybody's doing. I what you do like she's the person that you need to talk to for the details. And it doesn't hurt to sit down with the tutor. I don't have the tutor information yet. Again, for the tutor information, you'd have to contact the math office. They have the details on that. Whereas, because last time I spoke to them, I know they were still setting it up, and I know that my students, all usually the students like that's a invaluable service if I'm using that phrase properly. Um, so I know that they're working on it if it's not already fully operational. And I want to say those, I mean, they may or may not be on campus because I know that you all are. Um, but even if they aren't, then it would be remote or whatever. But those tools are there. And the thing with Alex is just get started. Like you just want to make sure that you're doing it right, and don't hesitate. Like once you do link with the tutors, don't hesitate to like sit down with them. Let me open up the chat real quick. Thank you, gentlemen. Yeah, I see you. Once you get into the, so I do let you guys into the Zoom one by one. I take attendance as I let you guys in. I've been kind of lax about attendance for the most part. Like as long as you get in within a reasonable hour, I give you attendance. Um, I want to thank the brothers for sharing. I think that was fantastic. Just good stuff. I'm pretty sure that what you guys are saying, you're not the only ones that having whatever issues or feeling whatever kind of way, and it helps your brothers to hear this kind of stuff. I would I like how the first gentleman, he felt like that was it for the exam. I was like, no, you can actually still keep working on it. And so I know that's a big thing because the exam is going to be the bulk of your grade. Um, Exams are going to be the heavy. Like if you don't do anything else in my class, you at least want to make sure your exams are in order. That's going to be the bulk of the grade, right? Like 80% of the grade are exams, maybe a little bit less than that, maybe like 70 something. Um, and then the homework is like 9% of your grade, something like that. Because of the lab component, it kind of makes it a little bit less than 10. So the homework is a lot of work for less points. So that's why it's available. I want you to do the best you can. Yeah, I got him. Do the best you can with the homework. But if you don't do anything else, you definitely want to make sure your exams are in order. That's where the bulk of your grade is going to come from. With the labs, you're linking up with Dr. Lamar and just following her instructions. Ask for help. The tutors, you got a lot of support. There was something else I wanted to mention, but it'll come back in due time. There were a couple of other hands. Feel free to unmute yourself. And Mr. Pendergrass, are you related to like Teddy Pendergrass? Is that the same last name? I've always wanted, huh? Gassed. I thought I was like when you said it today, it's like it sounded different. I was like, oh, but I get you get that. I bet you get that question a lot. I would imagine. Yeah. Okay. There was another hand before we kind of just. Okay, I'm not sure if he's still here. I'll let him be for now. Yeah, one of the students asked a question from the exam earlier. I thought it was a good question, and so we were able to get to the bottom of it. Um, it sounded like he had a different set of issues, but yeah, so that was interesting. Okay, so our exam was due this morning. I think we finally we did come to the conclusion that we still have time on it. It's just that after the due date, there's a 10% late penalty, so that means the highest you can make is a 90. The system is set to take your highest score. So anything that's on Pearson, that's how I do it. For exam two, so exam one was only over sections 1.1, 1.2, and 1.3. Exam two are the next three. So it's going to be 1.4, 1.5, and 1.6. And for that exam, I do want to incorporate an oral component. And so only thing that I really need from you on the oral component, I just need to be able to see your face. And then you just tell me what to write. All right. So like when we start doing that, I'll ask you some questions, make it clear, and then you tell me what to write, and I'll have my screen showing, and then we'll kind of go back and forth like that. And the oral component, I think I only want to make it like 20% of your grade. I don't want it to derail you like or anything like that. I just want to get some feedback. I need to be able to see you. You know what I mean? Um, Ali, I like some free. Okay, so let me see the time real quick. Yeah, we got a good amount of time. So what I would like to do today, I want to go ahead and start working on, because I've already done the lectures for section 1.4, 1.5, and 1.6. I did 1.6 this morning as far as the lecture. So those recordings are available on my channel. I would say watch the recordings, take notes if you're in class. Today we're on section 1.4. So since that recording, a fresh recording is there, what I was going to do today was start working on the assignments for section 1.4. Also be aware that with all of the online assignments, you can actually get ahead. Again, I went on and loaded all the homework for the semester and all the quizzes. The only thing that's not there on Pearson already are the exams. Exam 1 is available, but I haven't released exams 2 and 3. Okay. Let me see if Mr. There's still one hand. Mr. Is it Hale? Are you back, Lorenzo? Oh, it's no worries. I'll lower it. I think that was from earlier. Okay. So let's take a look at some of the questions from Pearson. So exam 3 left off with section 1.3. I think that was introducing functions. I think that's what it was. So section 1.4 was a library of functions. So what we're gonna do, let's hop over here. We're gonna hop to this one. Yeah, right here. You should be able to see this. So we're just gonna be working on section 1.4. So I'm just gonna continue with you guys where I left off with my students from earlier. Also, anything that you see me write, I just want you to be aware you can pull a copy of the PDF from our Blackboard page, okay? So this is question number 3 from section 1.4. We're asked to find the intervals over which the given function is increasing, decreasing, or constant, right? So with something like this, can I make this bigger? How can I zoom in? I think if I go like this. Yeah, okay. I guess that's okay. So with something like this, we can graph this, right? The highest exponent is a 1. This takes on the form y equals mx plus b. So you should be able to see that that's a line, okay? So then this has a y-intercept of -1. Let me get this student. Okay. So the y-intercept is -1, and it has a positive slope of 3. So, you know, we could graph it, look at the graph, but you should be able to visualize like a y-intercept of -1 and a positive slope of 3. So as we trace the line left to right, it goes up. So it should be A, right? The function is increasing. Nope, not that one. The function is never decreasing, but the function is increasing, right? We got a diagonal line that has a positive slope. So it's never decreasing and is increasing over the entire domain, right? So I'm going to put negative. It's increasing from negative infinity to positive infinity. Okay, I'm gonna hit enter. And now if I need to show that graph, just let me know. We can explore the graph. Let's see. Constant, so it's never constant, so I'm going to put no solution. I think that was it for that one. All right. So section 1.4, what this section covers is basically a library of basic functions. So I think when we talked about this in the past, the initial basic function was a horizontal line, like y equals some number. That's called the constant function, and that's just a horizontal line through y equals whatever that number is. The next one was y equals x, which is a diagonal line. That's like the one we just did just there. And then you got the y equals x squared, which is a parabola or the squaring function. You got cubic, which is like an s. So we had a whole list of like basic functions that we're exploring. So for instance, the basic function here is the squaring function, y equals x squared. So let me see. For something like this, I would look at the graph, right? You can choose several values of x, find the corresponding y, plot the points. You can also use a graphing utility, like we could use GeoGebra or Desmos. These are like, it's like geogebra.com or desmos.com. These are online graphing utilities, free online graphing utilities. So we could like type this in and see the graph. I'm just not gonna do that with this one. This is a parabola that's been stretched vertically, right? So we didn't move it around. So a parabola is like a U-shaped curve. If I need to show it, just let me know and I'll show it. Increasing, right? So if we're talking about increasing, so if we're thinking about a parabola with a vertex, a U-shaped graph where the vertex is at the origin, it's only increasing from the origin going off to the right. So that's going to be this interval here. It's increasing from 0 to infinity, right? If I need to show the graph, let me know and I'll show it, but I think you can visualize it. And then, so if we have increasing, we can also talk about decreasing. The function, so as we look at a U-shaped graph, as we trace it left to right, Initially, it's going down, and then at the vertex at the origin, it shifts, and then it goes back up, right? So it's going to be decreasing from the far left, which is negative infinity to 0. And again, I'm just not showing the graph, honestly, out of being lazy. But, if there's a request, I'll show it. Identify the interval over which the function is constant. So if we think about a U-shaped curve, right? At first it's decreasing, and then it goes directly from decreasing to increasing. So it's actually never constant. There's no interval where the function is constant. It looks like it almost flattens out, but it doesn't actually flatten out. Next question. Let me see the time. Okay. So the table is a complete representation of f. Decide if it's even, odd, or neither. Okay, yeah. Let me just write out these definitions really quickly. So we're going to hop over to the tablet. Right here, like this. I'm gonna make sure it's showing. Looks good. Okay. So even, odd, or neither. I just want you to see these definitions. I guess I can write it like this. Oh, are you doing that thing? You are doing that thing. Give me just a moment. I gotta reboot this. Right here. Come on. Cool. Okay, so just to recap some definitions. What do we mean by function being even? An even function, right? What does that mean? An even function means it satisfies the definition. Whenever we evaluate f of negative x, an even function means we're going to get back the original. All right, so that's one point of an even function. Again, whenever we do f of negative x, we get back the original. That means the function is even. That's the definition. A property of even functions, they have y-axis symmetry. Right? And then one other property, whenever we have x comma y, we also have negative x comma y. Right? So these are some properties. The main definition of an even function is when we do f of negative x, we get back the original. Okay. So then the next one, a function being even, we can also talk about a function being odd, or we could talk about odd functions. An odd function, whenever we do f of negative x, we get negative of the original. All right, you see the difference? Even function, we do f of negative x, we get back the original. An odd function, whenever we do f of negative x, we get negative of the original, right? If an even function has y-axis symmetry, an odd function has origin. You may have been tempted to say x-axis, it's actually origin symmetry, right? So origin symmetry, these are all like synonymous, the groupings or whatever. Origin symmetry is the same as whenever we have x comma y, we also have negative x comma negative y. So these are going to be, this graph is going to be symmetric about the origin. So all your points are going to be equidistant and mirror images as far as placement centered around the origin. And then if neither of these two properties hold, then we would say that the function is neither. So even function, f of negative x, we get the original. An odd function, whenever we evaluate f of negative x, we get negative of the original. Okay, so let's go back to that question. Okay. Let's see. So in this case, we have negative 100, negative 15. Then we have positive 100, positive 15, right? So notice that both of them change. Both the x and the y change. Did this happen for the next point? Yep, they both change, and it holds, right? So in both of them changing, that's indicative of the function being odd. That was a property of a function, of an odd function. Not only, basically they both change, right? Let's see, do we get another one of those? Okay, so here's another one. We want to decide if this is even, odd, or neither. So we went from we have a negative 120, and then notice that only the x's changed and the y stayed the same. Only the x's change and the y stays the same. Only the x's change and the y stays the same. So this should be symmetrical about the y-axis. So the function is even. That should be the function is even, right? Okay. Okay, so now let's see. So we conceptually get, again, a function being even means we have y-axis symmetry. A function being odd means we have origin symmetry. So then this question asks us to determine algebraically whether the given function is even, odd, or neither, right? So let's see how to determine whether a function is even, odd, or neither algebraically. I'm gonna venture and try to write without my lines. This is question number 7 from this assignment. This comes from section 1.4, question 25. I'm going to say, who is this? Oh, it's that same student. Okay, I need to find out who this is because I know they were here last time, and I know I didn't give them credit because I didn't know who it was. Let me let them in because I remember this from last time. Give me just a moment. Oh, I think I know who it is now. Let me see users. Okay, I just let someone in. If you're just joining the JAHRLK, I know you were here last week, but oh, I see it now. What's your last name? Is it Jarik? I don't know if you can hear me. Can you guys hear me? Ali Oxenfree? I think I see him though. I don't know if you guys can hear me. But yeah, but I noticed his name last time. I kept saying, "Hey, update." So you definitely want to show your first and last name. So like when you log out, just go and make sure that your first and last name is showing. Let me see the time. Um, because it just makes it easier. Like when I can't see your last names, then it's like, okay, wait a minute, who is this? Anyway, okay, but I found that student. So, and again, oh, let me check the chat. There's some activity. Yeah, and yeah, I saw you. I saw you last time. It's okay. Yeah, you don't have to speak. Um, I think it's Jari. Yeah, I saw you last time, but I couldn't find you on my roster. But I found you this time, and so I was like, I tried to. Yeah, just when you exit out, just show your student name, like put your first and last name, and that'll fix a lot of that stuff. I'm not gonna if I'm not gonna let the attendance kind of get in your way though. So like, don't worry about that. Just keep showing up. Um, okay, so let me just finish taking some notes. So this comes from section 1.4, question 25. And we want to determine if this is even, odd, or neither. Okay. And then we're given this g of x, and we want to determine algebraically. We have this g of x equals negative 7x squared minus 3. Okay. Let's hop over to the tablet like this. And that looks good. You, my friend, are totally distracting. Can you just like go somewhere? Cool. Thank you. Okay. Even, odd, or neither, right? So let's see how to do this algebraically. Again, even means y-axis symmetry. And we'll get into the definition in a moment. Odd means origin symmetry. So whenever I do a test for even, odd, or neither, first thing I do is replace each x with negative x, right? So we have, first I'm going to replace all my x's with a blank set of parentheses. So whenever I do substitutions, I generally replace each x with a blank set of parentheses. Now, what goes into the blank parenthesis in this case? We're going to replace each x with negative x. So the blank parentheses, what that allows is, it helps us to keep track of the negatives. Without the parentheses, we might view that first term as negative 7 minus x squared, and it'll throw us off, right? So whenever we're doing substitutions, we replace each x with a blank set of parentheses and then proceed, okay? So when doing the test for even, odd, or neither, the first step is replace each x with negative x. So the next thing we want to do is simplify, right? So now if we just simplify this, I'm bringing down my equal sign. So the first thing is this negative x squared. If we have a negative x times a negative x, negative x times negative x, double negative is positive. Well, actually, here, let me just space it out. I'm going to just write it out. So in this first term, what we're experiencing is negative 7 times negative x times negative x, right? And then we still have the minus 3. So that first term, we have 3 negatives that we're multiplying. So if we have odd number of negatives, will the final result be positive or negative? The final result there is going to be negative 7x squared, right? Minus 3. Is this the original? I think this is a yes, right? This is the original. So that's a yes. It's the original, or here, instead of writing it that way. So this is equal to g of x. So now we have g of negative x equal to the original. That's the definition of a function being even, right? So I think when we kind of revisited the definition of a even function, this was the actual definition. So that one should be even. Let me check the chat really quickly. Let's hop back over to Pearson and test it out. Now, once the tutors become available, I mean, if they're willing to, if they're willing to sit down with you, you can go through as many of these as you like with them. Like, you have a lot of support. You just got to take advantage of it. I determine if the function is even, odd, or neither. So, like for instance, with this one, if I were to show the algebra, that first term is ultimately going to be negative. That second term is ultimately going to be negative. We can factor out a negative from each of those terms, and we're going to get negative of the original. That's too much to say in my mouth. So it's a mouthful. That was a funny sentence. Let me write this out. I feel like it might be a little bit better visual if I just write it out. So this is question number 8. This comes from section 1.4, question 27. I'm going to say even, odd, or neither. Okay. And we're given this f of x equals, we got x to the 9 plus x to the 5. Okay. Let's hop over to the tablet. Okay. So again, whenever I'm doing even, odd, or neither, first I replace each x with negative x. So I got my f of x. I'm doing my blank parentheses. And what goes into the blank parentheses? Negative x. Right? Okay. Keeping my equal signs lined up. In that first term, if we have an odd number of negatives, the final result is going to be negative. The second term, if we have an odd number of negatives, the final result is going to be negative. Right? We can factor out a negative one from both of those. And we'll get this. Okay. But this is negative of the original. So we have f of negative x equals negative of the original. That's the definition of a function being odd. Okay. So I think we mentioned that a few minutes ago. We kind of revisited these definitions. So this should be odd. And that question actually came up for me in grad school, and I didn't know. I thought I knew what he was talking about, and it wasn't until I came back to teach this. I was like, why am I getting this question wrong? Like, what am I missing? And I just didn't know it because I never took this specifically or directly. I know how to do algebra, but it was some concepts here that I was missing. And then when I started teaching, I was like, oh, I see what he was getting at now. It just stuck with me. I'm going to write this one out. This is question number 9. What's the time? Okay. This comes from section 1.4, question 33, right? I'm going to say even, odd, or neither. Even, odd, or neither. Question mark, okay? And we got this x squared minus 3x over 5x to the 4 plus 6. And we got f of x equals that. Okay. Let's hop over to the tablet. Okay. So again, algebraically, if we want to test for even, odd, or neither, we replace each x with negative x, right? So first I'm going to do my blank parentheses. Like you should notice that we're essentially doing the same thing every time and then interpreting how the numbers play out, interpreting the results. All right, let me make sure I wrote down that question properly. X squared minus 3x, okay. So again, we're replacing each x with negative x, negative x, negative x, negative x. Okay. So now let's simplify. The first term, negative x squared. So that's going to be negative x times negative x. We have an even number of negatives, so that result is going to be positive x squared. The second term, double negative, becomes positive. The even number of negatives becomes positive plus 6, right? Is this the original? No. If we factor out a negative, that's not going to be negative with the original. So this is an example of something that's neither. This is neither even nor odd. Because we can't get back to the original, and there's no way to get to the negative of the original either. Okay. So let's hop here. Let me see the time. Okay, let's hang out for like I don't want to keep you past 3:45. I don't usually keep you past 3:45. But we got neither. Okay. Oof. Okay, let's look at this one. It says the graph of a function is given to the right. Use the graph to find each of the following. What's the domain, right? So in a graphical sense, oh, that looks so weird. In a graphical sense, the domain is the very left to the very right, right? So we ask ourselves, how far left does this graph go? There are no arrows. It stops right here, whatever this x value is. This x value here is -3. There are no breaks or gaps, so every x is accounted for, and then it stops the far right is 5. So the domain should be -3 to 5, and we include those endpoints in this case, so they should get a square bracket. So it should be every number from -3 to 5. Because we include the endpoints, the -3 gets a square bracket, and the 5 gets a square bracket. Okay, those grouping symbols are important. What's the range? The range is going to be the very bottom to the very top. All right. So now if we could instead of focusing on the x-axis, now we focus on the y-axis. How far down does the graph go? All right. So the lowest y value is -2, right here. Right. The highest y value is 1. So the range is from -2 to 1, and again they get endpoints because it reaches both of those y values. The function is defined for each of those. So it goes from -2, that's not a 2, -2 to 1, and I think both of these get square brackets. Okay. Determine the x-intercepts. Okay, x-intercepts are where it crosses the x-axis. I almost want to say the origin, but it might not be. So because this is kind of like a straight line, I'm going to find the equation of the line through those 2 points and then do a calculation to be more precise. Eyeballing, it looks like it's close to 0, but it also looks like it's not on the money, right? So, let me see. I want to take some notes. We got 2, 1, and we have -3, -2. Okay. I want to get some more information. So this is question number 10, and it comes from section 1.4, question 35. Okay. So let me hop over to the tablet so you can see. So these are the notes that I was taking, right? And basically, I'm just going to find the equation of the line through these 2 points. So again, whenever I have an ordered pair, my favorite thing to do, x1, y1, x2, y2, right? If we want to, let's start off with the slope. So slope formula, y2 minus y1 over x2 minus x1. So my recommendation is every time you use a formula, write it down. That constant writing of the formula, that's how you remember it. If you just use a formula without writing it, you probably forget it. But if you write it every time, you know, because we're creatures of habit, so whatever we do the longest, we do the strongest. Yeah, so every time you use a formula, write it down, and that'll help you to remember it. That's how I've learned it. So y2 I'm going to say this negative 2 minus y1 is 1. x2 is negative 3. I'm going to say minus x1 is 2. It's 2, right? Negative 2 minus 1 is negative 3. Negative 3 minus 2 is negative 5. Double negative is positive. So that's our slope. It's 3 by 5. Okay? So we don't have the y-intercept, so let's find the y-intercept. So I'm going to use the slope-intercept formula. I'm going to use y equals mx plus b, right? I'm going to choose the first point because that point just has less negatives, so it just like it's easier to deal with. My y value is going to be a 1. The slope that we just found was 3 by 5. The x value is 2. The only thing we don't know is b, the y-intercept, right? And we're going to need that in a moment, more than likely. So then ultimately, we get that b equals, if I subtract that fraction from both sides, it's going to be 1 minus 3 over 5 times 2, right? So that's going to be 6 over 5. So then that's going to be 5 over 5 minus 6 over 5. It's going to be negative 1 over 5. Ah. So we got our y-intercept. Okay. So then the equation of the line should be y equals 3/5 x minus 1/5. Okay. So then if we want the x-intercept, we set y to 0, right? So if we set y to 0 and solve, 3/5 x minus 1/5, we add the 1/5 on both sides, we get, I'm going to just write it like this, 3/5 x equals 1/5. We could multiply both sides by 5 or 5 over 3. Okay, I'm going to continue over here. So you can divide both sides by 3/5, but dividing by 3/5 is the same as multiplying by 5 over 3. So when we divide fractions, right, is the same as multiplying by the reciprocal. So now on the left, these become 1, very Zen-like, and on the right, these 5s cancel, become 1, and we're left with a third. So we're left with x equals 1/3, right? That's the x-intercept. So see, notice how 1/3 is close to 0, but it's not on the money. So if we had put 0, it would have been wrong. All right. So we got an x-intercept of 1/3. Okay, let's hop over. See, we got people hanging in there. Let me see the time. Okay, yeah, this will probably be it. Let me just try to wrap this one up. X-intercept, right? Use the comma, separate. I'm just going to put 1/3. So notice how it's close to 0, but not on the money. Okay, they almost baited us. The y-intercept, I think we just found the y-intercept. We got a y-intercept of a negative 1/5. So I'm going to put negative 1 over 5. Cool. Is that it? No? Yes? Continue. Identify the intervals over which the function is increasing. Okay. So increasing means as we trace the graph left to right, it goes up. So notice if we start from the far left, as we trace it left to right, the graph is going up. So it's increasing as x goes from negative 3 to 2. So it's increasing as x goes from negative 3 to 2. I'm under the impression that we're supposed to always use parentheses based on the definition when we're doing increasing, decreasing, or constant. Some books don't do it that way. For right now, whenever we're talking about increasing, decreasing, or constant, just use parentheses across the board. Okay. I think we're almost done with this one. Decreasing, it's not decreasing anywhere, so the function is not decreasing on any interval. And I think there's probably one more. Constant. Now it is constant. It's flat as x goes from 2 to 5, right? So it's flat on the interval from 2 to 5. And I think for this discussion, we should just use parentheses across the board. for increasing, decreasing, and constant, which use parentheses. And that comes out of the definition. Is this function even, odd, or neither? So even means y-axis symmetry, right? So if you fold this on the y-axis, notice they clearly do not match up. Odd means it's symmetric about the origin. So because it doesn't pass with the origin, or odd means whenever we have x comma y, we also have negative x comma negative y, so that's not the case. All right, it's just not the case. So it's neither even nor odd. So I'm gonna say neither. Just trying to wrap up this question and let you guys go. Okay, that was it. Okay, so I do have one more class that starts in about 15 minutes. Did anybody have any burning questions? If there are no burning questions, we're going to end the session here. All the stuff that you see me writing, you can pull a copy of it. I make it available on Blackboard. We're going to end the session here, guys. From one beautiful mind to another. Enjoy the rest of your day. Peace.